Assalamualaikum dan salam sejahtera. Welcome to the Physics Unmasked video series. In this video, we will discuss about vectors and scalars. Physical quantities fall into two categories: scalar quantities and vector quantities. Now, how do we differentiate between scalar and vector quantities? Well, scalar quantities are those that have only a numerical value or magnitude, and it has no associated direction, whereas vector quantities have both magnitude and direction. Now, example of scalar quantities like temperature, time, mass, luminosity, and energy, and so on. While vector quantities, you have force, velocity, acceleration, electric and magnetic fields, momentum, and so on. Since vector quantities have both magnitude and direction, how do we show or present these properties? Well, the graphical representation of vectors are as shown here on the right. For example, we have a force vector F, whose magnitude is the length of the arrow, and the direction of the force acting is in the direction of the arrowhead. Now, if you have another same magnitude force, but points in the opposite direction, this force is drawn this way, and the arrowhead is pointed to the left. Normally, we would place the vector on the xy plane of the Cartesian coordinates, x and y, so that we can specify its magnitude and direction with respect to this coordinate axis. For example, this velocity vector v, has a magnitude of v, and the vector is located theta degrees, measuring anti-clockwise from the positive x-axis, x, y. Another vector such as pressure P, and is acting downward, and with respect to the xy axis, this pressure is acting toward negative y axis. Electric field is also a vector. So for example, we have an electric field vector this way, and it has a magnitude which representing by the length of the arrow E. That's the magnitude of the electric field, and with the xy coordinate axis, the direction of this electric field vector is measured from the positive x-axis anti-clockwise toward the vector E. So that is the direction of electric field vector E. Let's see quickly how vector quantities are added or subtracted. There are two methods: graphical method and component method. In the graphical method, to add vector A and B, just place the base of vector B to the tip of vector A. The resultant vector is an arrow line drawn from the base of A to the tip of B. Let's call this vector R. R is the sum of vector A and vector B. Now, if you want to subtract vector B from vector A, first you have to change the direction of vector B, and then place the base of vector B to the tip of vector A. And again, the resultant vector is drawn from base of vector A to the tip of vector B. So R is now the resultant vector. R is equal to vector A minus vector B. The other method of adding or subtracting vectors is by using component method. Okay, but first we have to look at what are components of vectors. Components of a vector. Components of a vector. Consider a vector A laying in the xy plane and making an arbitrary angle theta with the positive x-axis as shown in figure here. This vector can be expressed as the sum of two other component vectors ax, which is parallel to the x-axis, and ay, which is parallel to the y-axis. From the figure, we can see that ax is the projection of vector A along the x-axis, and ay is the projection of the vector along the y-axis. If we move the component vector ay and place it at the tip of component vector ax, the three vectors a, ax, and ay form a right angle triangle. Thus, we can see clearly that the vector A is equal to the sum of its component vectors A equal ax plus ay. We can get a relationship between vector A, ax, ay, and theta if we apply the sine and cosine rule for the right angle triangle. That is, cosine of the angle theta is equal to adjacent, which is ax, divided by hypotenuse, which is a, and sine of the angle theta is equal to opposite, which is ay, divided by hypotenuse, which is equal to a. So that we get a cos theta and y equal a sine theta. Furthermore, the magnitude of vector A is equal to the square root of square of the sum of its components. And the angle theta is equal to tangent inverse of ay divided by ax. Notice that the angle theta is measured counterclockwise from the positive x-axis around the circle. As a result, the ax and ay can be a positive or negative values depending on the angle theta. If theta is equal to 140 degrees, then ax is negative, ay will be positive. If theta equal 240 degrees, both ax and ay will be negatives. Now, how do we specify a vector in writing? Well, you can specify a vector either with its components ax and ay, or by specifying its magnitude and direction a. That means its magnitude a and direction theta. Very often, vector quantities are specified in terms of unit vectors. Unit vector is a dimensionless vector having unit magnitude, as shown here. So, in 2D, that is xy plane coordinates, a vector A is drawn as shown in this figure. And in writing, in terms of unit vector notation for the vector A, it is written as ax I hat plus ay j hat. Again, the components of A are still ax and ay, and the direction of the component vectors follow the direction of unit vector. That is, I in the positive x direction, j in the positive y direction. Okay, finally, how do you write or specify a force vector having a magnitude of 10 Newton and direction angle of 36.87 degrees. In terms of magnitude and direction angle, this vector can be written as 10 Newton, 36.87 degrees. And the vector in terms of its component is written as 8 Newton, 6 Newton. And finally, in terms of unit vectors, this force vector can be written as 8I unit vector plus 6J unit vector. So these are the three notations used to specify a vector in writing.